Hello and welcome to another video. In this video we're going to be going over reverse substrings between each pair of parentheses. And in this one you're given a string S that consists of lowercase English letters and brackets. And you want to reverse the strings in each pair matching parentheses starting from the innermost. Your result should not contain any brackets. So here there's only one bracket, so you just reverse. And here basically what's going to happen is, I wonder if I can actually do this. So we're going to have like this, and then we're going to have a U, and then we're going to have a love. Now we hit a close parenthesis. So what we need to do is we need to take this love and reverse it. So we're going to reverse it, so it'll be evol. And then that parenthesis is gone, and we have an I that we haven't closed. So now we're going to take this, and we're going to reverse this as well. So I think, does it let you reverse? No, okay. So basically, yeah, we just reverse it, and it would just be like, I love you. And in this next example, so we have ED, ET, OC, then we have a close parenthesis, so this OC should be reversed, so just like this. Then we have another close parenthesis, so this ETCO should be reversed. So it should be OC, or actually it'd be the other way, or no, yeah, it'd be OC, TO, I think, something like that. And then we have the EL, yeah. And then it would be like this. And then you reverse again so we get LeetCode. So one thing you could do is basically every time you have an open parenthesis, have some kind of like a stack, and every time you have an open parenthesis, add a new thing on the stack, and then whenever you have a close parenthesis, you just reverse it. So that does work, but the problem is, let's say you have something like this. You have a bunch of these, and then you have like a big word. So big word, yeah. The problem is you're just going to be reversing your big word, like left, right, left, right, left, right, left, right, left, right. And it's not going to be that great because let's say like this is 2,000 characters and your big word's like 1,000, and then you have 1,000 open and close parentheses. So you're basically going to do the number of reverses equal to close parentheses, which is like 500. And then your complexity will be n squared. And so there's another way to do it. I will say it's pretty tricky, to be honest, to figure out how to do it. But it's basically involving the fact that instead of actually doing reversing, we can just jump from one parenthesis to another, because when we do a reverse, basically what that means is read from the other end. So if we know like we have like this, let's say we have that big word example, we're basically gonna, as soon as we have like an open parenthesis, we're gonna just jump to its matching close parenthesis and then go backwards. And so we're gonna jump, and then we're going to end up actually on the big word, and then we can just traverse it one time. So that'll give us a linear solution. So this is pretty hard to come up with, to be honest, but let's kind of walk through how this works and how to do it. So the first thing you need to do is for every open parenthesis, you need to like have the index of the open parenthesis and the closed parenthesis so you can jump back and forth. And then the other thing we need to maintain is like which way we're actually going. Because like if we were going left and we hit a parenthesis, we need to reverse. And if we were going right and we hit a parenthesis, we need to reverse, and so on like that. So let's go through this example 3. Probably in an array like this. And let's walk through like exactly what we're going to be doing. Maybe we need a big array, we'll see. So ed open et. So you do need a little bit bigger. Okay, so this, and then we need 3 more. So let's just do this. Okay. So 10, 11, 12. And then this is like this. Maybe we need one more actually. Yeah. Okay. So let's just have one last one. Be like this. 13. Okay, so let's just double check. So EDT, OC, yeah, that looks good. Okay, so essentially what we first want to do is we want to create a hash map of like every open parenthesis, right? Its close parenthesis location, and then the other way around. So if we're on one, we know where the matching one is. So we can just walk through here, and then every time we hit, so you can actually do this with a stack. That's the easiest way to do it, I think. So basically what we're going to do is every time we hit an open parenthesis, we'll add it onto the stack. And then every time we hit a close parenthesis, that close parenthesis is going to match the rightmost open parenthesis we have. Right? So like for example here, this will be our stack. So I'm just going to take these items off and show them over here just to show where the location is. So like we hit an open, so we're going to add this to the stack. And we're just going to add the index, but I'll just show it like this to make it easier to see. So, and then we keep going. We only care about open and close parentheses. We hit another one, so we're going to add onto the stack. Then we hit another one, add onto the stack. Okay, now we hit a closed. So like I said, the closed is going to match because if you think how parentheses work, whenever you hit a close parenthesis, the open parenthesis it matches is going to be the rightmost one that we've hit so far. So it's going to match this guy over here. So the 6 and this 9 should match. So we're going to pop this guy off the stack, and then we're going to say that 6 maps to 9 and 9 maps to 6. Okay. And then same thing here. So 3 maps to 10, 10 maps to 3. And then we'll hit this guy last, which will be 13 and 0. So same exact thing. 13 and 0. Okay, so this is our hash map of like our matching parentheses. So if we hit an index that's in here, then we know where to jump, right? Like if we hit a 6, we know to jump to a 9. If we hit a 9, we know we have to jump to a 6. If we hit a 13, we know we have to jump to a 0, and so on. And then the other variable we're going to keep track of is direction. So initially we're going right. So we'll say like it's going to be an integer, and we'll just make it 1, meaning if you're at some index and you want to go somewhere, you're going to add this direction, and then to reverse we'll just like make it -1. So we need this, and we also need like where we currently are. So let's call that current. So actually I'm not going to show the current, I'll just show it with the little with the thing here, and then we can do it, and then we'll have our actual result string. Okay. So the first thing is we hit a parenthesis. We're going to start here, we hit a parenthesis. So we know that like we have to match its close parenthesis, wherever that is, and then start going backward. So its close parenthesis and we basically are going to keep doing this until we get out of bounds. So its match is over here. And our direction now swaps because every time we hit a parenthesis, our direction will swap. Because we're going left, or we were going right, now we want to be going left. So this is the match, and then we need to go in this direction 1. Because we don't care about the parenthesis, we just care about the next letter. So we have an L here. So if we have a character, we can just add it into our result. So we'll add the L. Then we're going to keep going because the direction is negative. So we're going to keep going negatively until we hit something else. So we have the E. Now we hit a parenthesis again. So that means we want to hit its matching parenthesis and then reverse the direction again. So its matching parenthesis, 10 is 3, and then we reverse. And so if we reverse, we're going to go this way now. And so we have the E. And then we have the T. And now we hit an open parenthesis again. So we're going to see where is its match. Its match is at 9. And then we reverse again. So we're going to go left, and then we hit a C. So this is kind of the idea, is like every time we hit a parenthesis, we know we have to go to the other one and we have to start going backwards, because that's what a reverse basically means, right? Like if you reverse a list, you just go, if you were at the start, you just go to the end and then you read it backwards. That's what a reverse is. And so that manual reversing, we're jumping, so we're reading efficiently, but not actually doing flips. So then we have the C and then the O, right? Because we're going to have C, O. Then we have this. So now we are going to jump to its match, which is at 9. Yeah. So its jump is at 9. So we're going to go over here. And then we're going to reverse again. So we're going to go this way. Now we hit another parenthesis, so we're going to go to where this maps. So this maps to over here. And then we're going to reverse again. And now we're going to go here. So D and then E. So DE, then we hit another one. And now that we hit this open one, we're basically going to go out of bounds. So as soon as we hit like the first open parenthesis, we're going to go out of bounds because we will go to the one that matches and then reverse. And now we just go out of bounds here. And then we're done. So it's kind of like a cool solution, kind of hard to come up with. The brute force actually does pass because n squared, like the constraint is pretty small. So I think if you're doing like an interview or something, I would do the brute force, but this is kind of clever, so kind of cool to see. But yeah, I think like it's pretty hard to come up with, to be honest, I think, during an interview. But yeah, if you do think about it, it makes a decent amount of sense, because basically when you have something in between parentheses, in order to reverse, all you do is jump to the other parenthesis and then you start reading backwards. And you just keep doing that. And then whenever you hit the same thing again, you will basically jump here again, and then you'll just go the other way and you'll be out of bounds. So that's what we're going to code. So the first thing is we need to actually have the map of every parenthesis to its like match. So let's do that. So we'll have a map. Call it like parens or something. And then we're going to have a stack of the thing that I was saying, right? So we're going to traverse and put open parentheses on the stack, and every time we hit a close, we'll pop off the stack, and that will be the pair. And we're guaranteed to, like, whenever we pop off the stack, like whenever we hit a close, we'll always have a stack, because this will have valid parens. We don't have to check if like this thing is valid. It'll always be valid. Okay. You could use a stack, but I think no one uses stacks in Java. I think you can just use a list, which is better. So yeah. Forgot exactly why, but I'm pretty sure like basically no one uses stacks, so we'll just do this. Okay, so we're gonna go through our thing. And we'll basically just say if it's an open paren, add it to the stack. If it's a close paren, pop off the pair. And if it's a letter, we don't care. So if this is an open paren, add it in. And like I said, we only care about the index. We only care about the index of the open paren and the index of the close paren. We don't actually need to say like what letter it is, because it'll always be an open paren. So if it's a closed paren, then we are going to pop off the stack. So we'll say like the other location is stack remove last, I think we can use. And then we just put these into our map. So I guess I called it parens. Put ij, and the same thing the other way. ji. Okay. So this will give us our like bidirectional mapping of the parens. Then we need to go through it again, and we need to have a direction variable, like I was saying. So our direction will be 1. It'll be positive to the right. And our location, we can just choose I again. It'll be 0. And then we're going to have a string builder for the result. And another language, you can just use like a character array, whatever. For most of these string things, you just want to be adding characters and then do a join at the end. Which is going to be the best way to do it. So basically, as long as we're not out of bounds, let's keep doing this. So while I is greater than or equal to 0 and I is less than this length, we'll just keep doing it. So all we really care about is two things, right? If it's a paren or not. And if it's a paren, it's going to be in our parens map. So if parens get key, or actually contains key, I, then what we need to do is we need to jump to its pair, and we need to flip the direction. So we're actually going to flip the direction first, and then we're going to say I equals the pair plus the direction, because we don't want to be on like the parenthesis. We want to be, this is parens, we want to be like 1 after that, depending on which direction we're going. Otherwise, we have a character, so we can just add it to our result. And then we can add the direction, right? So if we have a character, we just keep going in the same direction we were going. And finally, at the end, we can return the string builder to string, or join of your array, or whatever you're using. Yeah. Okay. Yeah, and this is like the best solution for it. Like I said, kind of tricky, and then squared a slow pass for that. And I think that one's like, you should be able to come up with an n squared one. This one's a little bit tricky, but definitely the n squared one is not super hard. You just basically, every time you have a paren, like I said, add to the stack, do reverse, and yeah. So this one is a linear time and a linear space, because so we have our stack, like Technically, our whole thing could just be parens, which means your stack will be full and your parens thing will be full. So, yeah, there's like no limit to the number of parens you can have. And then we're going through this thing twice. And we're basically never revisiting. I guess we are revisiting some things, but not very often. And usually when we revisit, we just go out of bounds. So let's see what this actually says. I'm curious if it... This one is actually kind of hard to figure out complexity in a thing. Oh, I did figure it out. Okay, cool. Okay. I'm curious if they use this, like, and this is per problem or not, or it can just, like, tell. Kind of. I don't know. Okay, well, whatever. But yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.